Breaking Barriers, Paving the Way for Autonomous Vehicles. That's the title of our session. And I would like to welcome everybody to our panel. And I would like to thank you for taking your time to join us in this fantastic global 24-hour format. I feel very honored to moderate our session. Why? Because I can present to you the who is who in the field of AI and autonomous driving. My panelists are great experts and senior leaders, and we can be very happy that they join our panel and enrich our discussion with their views and experiences. So let's welcome Mark Alexander Peters. He's the head of Mobility and Transport as a Service and the Autonomous Program Management Office at Volkswagen Light Commercial Services. Let's welcome Cyril Duot, who's Vice President Strategy at Mobilize of the Renault Group. Let's welcome Philipp van den Berge, Vice President Automotive for the region EMEA from NVIDIA. And let's welcome Wolfram Burkhardt, Professor for Robotics and Artificial Intelligence at the University of Technology, Nuremberg. So we are talking about autonomous driving since quite a time. And some experts had already anticipated the tipping point at the beginning of this decade. And we all know that we are not yet there. So I would like to turn with my first question to Wolfram. Why is it taking longer than expected? And why is maybe also autonomous driving so complex?
Okay, thank you. Thank you for this question. It is actually a very interesting that people are always overly optimistic when it comes to solving problems. And turns out that building a self-driving car means to basically build a robot in the end that is able to understand the world and act in the world in a way that is like better than humans. And this is quite a challenge. And it basically also means that we do need to have the ability to build systems that outperform ourselves. We have seen this in certain areas, like in games, for example, but it is actually very hard to build AI systems or AI-based systems that can do this in everyday life and in the complex world that we live in. That basically means that the reason for this is that perception is extremely hard. I mean, dealing with all the aspects that are involved in driving, doing this under all weather conditions, in rain, snow. It can even be like different surface properties of roads. Let there be leaves on the road, or let it be ice on the road or snow. Things like that. This is all extremely complicated. Then there's issues with, for example, prediction, basically making proper prediction about how the world is going to evolve, just to name a few aspects there. And then if you think about this like machine learning or deep learning hammer that we are now trying to throw at this problem, in the past we have mostly done this with supervised approaches, which are extremely expensive when it comes to the development, and you don't have a right answer to this right currently. This is basically also the barrier for level 5, meaning that we can drive everywhere. So that what we see right now is basically vehicles that drive in geofenced applications or geofenced settings, which is something that you can develop, but opening this to a broader market is quite a challenge, and it's unclear how we can actually achieve this.
Okay, so we are in a global session for artificial intelligence, 24-hour, and we are talking about autonomous driving. I mean, where exactly is the area where artificial intelligence can support this autonomous driving approach?
If this question goes to me, then it's definitely in the perception part, and it's also in the in the prediction and planning part. So basically predicting how the world is going to evolve and what the next best action is supposed to be. But I also leave this to others in terms of answers.
Okay, and maybe I just finish with one question that I would like to address to you because you are a professor. I mean, why would you recommend a young student to engage in the field of AI and autonomous driving?
I mean, this has several reasons. First of all, I believe that we live in the century of AI and machine learning. This problem will, this topic will not go away. And it is extremely important for industry to stay competitive, to basically invest into the space and trying to use AI as much as we can to actually increase the capability and reliability and also versatility of the products, and services and of the future. So this is something. So this is a highly important area, and automated driving is just one aspect that has also societal relevance. I mean, we all want to have safer traffic. And automated driving doesn't necessarily mean that we only have vehicles that drive themselves. The impact is something that we see already also in the ADAS space, driver assistance systems. We basically have more or better driver assistance systems right now that also impacts the safety of traffic. So, and that in the long run will also impact other fields like logistics, agriculture. Like we will basically be able to build better robots that can be applied to different areas as well. So it's a great and important area to be in, and it has a fantastic future.
Thank you very much, Wolfram. So I would like to turn to Mark now. I mean, you are engaged in the services business very heavily for the Volkswagen Group. And I would like to ask you, where do you see attractive services with regard to autonomous driving?
Yes, because, you know, I'm responsible of our robotaxi program, where we heading for the end of in 2025 to be on the streets. Of course, I deeply believe in this autonomous mobility. So there we have two fields, like in my title, two abbreviations. This is mobility as a service. So this is really a robotaxi where we see in Europe, especially pooling services will be there, especially due to regulatory requirements. We see the cities, you know, they want to get the cars out of the cities. And we see really that, you know, pooling can be really a good opportunity to combine efficient mobility with a high comfort level. So this is especially on the view on Europe. In the US, well, there we see is a little bit more a hailing market, so what we call a classical taxi. And these are both main fields we do in mobility as a service within these two regions. On the other hand, what is really important for us as well is that we see this transport as a service as a solution. This means is to travel goods with autonomous vehicles from A to B. This is our second business area where we focus on.
You talk about your services. I'm sure that you also, with your experience, have an idea of the critical key success factors that you need in order to leverage those services. What would they be?
Yeah, we're absolutely convinced that two items are important. One item is definitely to understand really the end-to-end business. You know, especially for us as an OEM, we are used to sell cars to end customers, or to fleet customers. This is our normal business. When we think about, especially about mobility as a service, then you have a complete different customer structure. And so you would not provide only a car, you provide more a service. And we see, especially with all the digital services, that is really a huge challenge for OEMs. And so one topic we really focus on and we see as a competitive advantage is to really understand the end-to-end service. And this is why we are really proud to have Moja within our company. So Moja is really successful in Hamburg with the right pooling service, really at scale. And so that really brings us in the position to really understand this business from an end-to-end perspective. This is the one point. The second point from our perspective is that it's all regarding, or most of the things are regarding cost. Yeah, it's always safety is always the top priority. That's for sure. But the second priority after safety then is really bringing the costs down. You are challenging at the beginning of the market mainly regarding cost with the human driver, of course. Yeah, and so I think that's not really only challenging cost-wise, because we have a shortage of drivers all over the world, nearly, especially in the two regions we address with the EU and with the US. So you have to be better cost-wise than the human driver. And then when we see autonomous driving and the autonomous driving system more in the field, of course we have to be better than your competitors on this end-to-end chain, that you are lower in the cost and have an adequate comfort level in the vehicles. I think these are the main points for us to be successful in this business.
And if you compare between business and private use, do you see any differences in autonomous driving services?
When you mean, we are differentiate between owned mobility and what we call shared mobility. Yeah, what we do with our robotaxi program is shared mobility. In the owned mobility, yeah, there we see a little bit more that this ADAS system, so what is called level 2+, yeah, so more in really an assistant with a good performance will enter in a broader range in the market in the next years. What we are doing with the robotaxi is really autonomous driving, and yeah, this is as I told, we see for the mid of 2025, and the difference technical wise is for the private use case. Yeah, you can maybe do the first really autonomous step, like we see it now with some competitors out of Germany. Yeah, you can do it in really certain situations, for example, on the highway or certain parts of the highway. On the other hand, in our business, yeah, you can do everything in a certain, so we call it operational design domain. So in a certain area, under certain conditions, you can drive everywhere. So we are really focused on urban mobility, like I pointed out. And so, for example, where Moja is actually in Hamburg, they have really a certain service area, and within the service area, within this operational design domain, the vehicle is fully autonomous, yeah, and can provide a fully autonomous service. I think this is the key differentiation between owned mobility, autonomous driving, where you see functions partly in some domains, and we have the full function in a fully domain. Yeah, and this is the key differentiation from our perspective.
Mark, I would like to turn to Cyril. When you think about autonomous driving, which areas are for you the most promising ones?
Well, there are many different use cases in autonomous driving. You talked about private use, so typically L3 for personal cars, enabling the driver to take his eyes away from the road, being ready to retake control and drive if requested. So this will come. We forecast it's going to be probably standard in premium brands, especially in the US and China, in just a few years. But I would like to focus a little more on L4 for people mobility and L4 for goods transport, because L4 will actually bring a big advantage, a lot of advantages. Without the day you can remove the driver, of course, the safety driver, otherwise there's no economic equation. So the L4, if you look at it, there are very different solutions and capabilities, with the two main complexity factors being the speed and the complexity of the ODD, the operating design domain. And to simplify what the ODD is, you can have a vehicle that operates in a very controlled and safe environment, such as a protected bus lane, or in the contrary, in open road with other vehicles, bike, pedestrians, etc. So small introduction to your question, because we know that well-known players in the US and in China are betting that AD will be a game changer for ride-hailing and for long-distance logistics. And they're probably right, because clearly there's a lack of drivers, like it was said before, and these are two huge markets, ride-hailing and logistics. But these players are actually targeting what's the most complex in AD, because you need high speeds and you need to go in open roads without any control about what's happening around it. So this will come, this will take some time, but in the European context, which is actually more complex than the US, driving conditions are more complex in Europe than in the US, other use cases will develop in parallel to ride-hailing and logistics, with simpler use case, lower speeds, and control ODDs. So just to give you some examples, we know there's some demand for AD solutions in closed sites, for example, large industrial sites, nuclear plants, some residential areas, etc. Which it's simpler, clearly, than ride-hailing in open roads. In addition to this, you can think that public transport on defined routes will also develop in complement or in replacement of buses, because actually AD will bring more flexibility, because you can have more vehicles on the road. At one point, you can have larger, let's say, schedules, because you're not dependent on the availability of drivers. And this will develop, and it will even allow to develop new mobility solutions in peri-urban or rural areas where currently there are very, very mobility solutions for people. So I see this new use case as bringing new social advantages to populations, because more flexibility, more solutions, probably more affordable as well, because when you actually remove the cost of the driver, which is something between 50% and 70% of total cost of mobility, even if the technology costs something, you can actually propose cheaper solutions. So to answer shortly, ride-hailing, logistics, but also simpler use case in complement to public transport or in restricted and closed areas.
Thank you, Cyril. So you're talking about those interesting and promising areas, but I think it's even more promising and interesting if it's really scaling. So what do you think are maybe at the moment requirements that we would need in order to scale up autonomous driving?
Yeah, there are many requirements. You're right, absolutely. First, you need the tech capabilities. That's a given. And typically the ability to demonstrate that you can reach a safety level that's higher than professional drivers. I'm not even talking about any driver, professional drivers. So that's clearly a big challenge, and that will certainly be the main driver when scaling up. Second, and it will be necessary to remove the safety driver, because we know that there are plenty of AD experiments in Europe, in the US, in China, where actually we're keeping someone in the cockpit just to monitor that everything's going right, being able to retake control of the vehicle, so the person we call a safety driver. That's not sustainable. I mean, you need the ability to remove the safety driver. Otherwise, again, no economic equation. Second point, we need favorable public policies. And I say policies because it's not only regulations. Usually regulations enable AD. They already exist in Europe. It's not an issue again in China. It's not an issue in the US. But we need to have favorable mobility policies of territories. We said earlier that large cities in Europe are trying to ban vehicles from the center of the cities. If you want AD to play a role, you need to have a favorable policy environment so that autonomous vehicles will be able to enter these territories. You also need a public support in other forms, for example, in the form of subsidies, because there are huge costs at the beginning to launch new services, or public support in the form of infrastructures. For example, if you want to have dedicated lanes, protected areas, etc., there are some infrastructure investment to be done. And last point, to scale up, you need public acceptance, which is not a small topic, because it's not only about being afraid of being in the vehicle or being outside of the vehicle and seeing an autonomous vehicle. There are plenty of other topics. For example, even if there's a lack of driver, you can expect that some drivers will react if AD developed. So I think mostly these 3 points: technology, safety, public support, and public acceptance.
The last question for you, Cyril. What do you think, what role do partnerships and alliances play in autonomous driving?
I think they're paramount. They're very important. They're crucial. Typically, there's a huge number of roles in the AD value chain. Now, of course, you can think about the AD tech with the software part, the hardware part. You have vehicle design, vehicle robotization, fleet management, mobility service operations, supervision, etc., just to name a few. And I don't think that one single player can control all the value chain. A car OEM, for example, can focus on vehicle design and vehicle robotization. Then we'll have to partner for the tech, the mobility operations, supervision, etc. We at Renault, a little more than 5 years ago, we decided we would not develop internally an L4 technology, but rather we would partner with tech providers, depending on the use case. So that's one approach. Other OEMs have decided to join forces to develop an AD technology to share the cost of the investment. That's another approach. But clearly, that's not one single player who can control the whole. And it's really about partnering. And there's of course, nothing in AD is a commodity now. I mean, you can't go to the Walmart and buy the AD tech you're going to put on your car. So it really needs a very partnership approach. I would like to add that in the French environment, there's some kind of club organized by the Ministry of Transport and involving OEMs, tech companies, public transport companies, and other stakeholders, sharing information about their plans, about explaining what they need in terms of regulatory, in terms of support, etc. So it's really an ecosystem approach. I mean, of course, we all have our business secrets, so we don't share our secrets, but we share everything that needs to be shared so that we can all together prepare for the future of AD.
Thank you very much, Cyril. So I would like to turn to Philippe. So we have talked about those amazing possibilities with autonomous driving, and I would like to ask you, what requirements do you see that autonomous driving is imposing on hardware and software?
Hi, Elmar. Thanks for the question. Hi, everyone. Before I talk about that, just want to say you started with the interesting point of talking about the tipping point at the beginning of the decade that everyone thought we would have achieved in AD or AV. And I think you asked Wolfram, why is it so complex? Why is AV so complex? And you know, it remains a very, very challenging problem to solve. I think all of us kind of touched on it in our panels today that, you know, since 2015, when I joined NVIDIA, we were launching, you know, platforms or chips, and we've evolved into building a platform. But we thought we could solve the AV problem with a 20 TOPS chip, right? And it was in 2017, 2018. And then we launched a chip called Orin, which is 250 TOPS, 250 trillion operations per second. And what we see is that there are some companies in China that are putting 4 of these chips in their cars in the meantime. So they have 1,000 TOPS. And our next generation chip called Thor is going to deliver 1,000 TOPS. And so, you know, the problem of AV, whether it's autopilot in a passenger car or whether it's a robotaxi shuttle, is so pervasive. It's related to the maturity of the sensors. It's related to, you know, the accessibility of compute. It's related to the ability to access data and to curate data and to know how to deal with that data, whether it's in the cloud or with an on-prem supercomputer in infrastructure. you know, and so to your question about, you know, why this is an interesting area for students and universities, you know, I think fundamentally this problem hasn't been solved. And for someone at university that wants to dedicate their life's work to solving a really hard problem that has many societal implications, I think this world of AV is probably more exciting than ever, to be honest. I just wanted to say that. So you know, this tipping point, I feel the maturity of compute, the maturity of sensors coming from all the sensor providers, the know-how around how to deal with data. I think we're close to the tipping point of you know, understanding how to solve the problem. And then the breakthrough around ChatGPT and Gen AI, which you guys will be talking about later, I think can contribute to this tipping point. Requirements. I mean, requirements is a funny word, right? When I think about requirements, I think about a big fat book, 500 pages. You know, what are the requirements? I don't want to talk about that, but I think I'd want to take it a step higher. So starting from first principles, from our perspective, what's key to a system is programmability, and that's what's in our DNA. If an AD solution is defined in a hardware-centric way, what we see there usually comes a certain amount of misalignment between the hardware and the software, and basically the hardware becomes almost out of date the moment it's already put in the car. And of course, there's a lot of expertise in hardware in the industry. And you could argue that there's still a lot of learnings around software in the industry. So it's normal that when people start defining hardware, you know, when they start defining their AD systems, they start with the hardware. But actually, you know, how do you define the solution when you haven't built the software or have limited experience doing so? That's part of the complexity. And so we would argue that the starting point is understanding what kind of infrastructure and platform you need to develop the software. That's not per se the chip in the car or in the vehicle. You know, this problem is about collecting data. It's about curating. It's about labeling. It's about training. It's about validating. It's about simulating, and that on a continuous basis at a large scale. And this is why the requirements of the computer in the car should be driven by this realization that software will be upgraded continuously during the lifetime of the vehicle. This is even more so for fully AV capable cars or buses or people movers. And to the fundament of that is this concept of programmability. And I don't want to not talk about functional safety and safety because, you know, this is a foundational pillar. And so in any question with requirements for hardware and software for AD, then of course you should comment on safety and make sure that's aware. But I think this is our thinking at the moment. So very much around programmability.
When you think about those aspects, programming, the high performance compute platform that you're describing, how important is it that you have open platforms? Does it matter?
Well, that is related also to the strategy someone, you know, a company has when it comes to launching ADAS AV systems. But you know, what fundamentally does make a platform open? And that maybe that's a good question to start with. At the end of the day, a platform that is open is probably going to have a pretty large developer base that is accessible in the open market. No different than Apple or Android, basically iOS developers. And the reusability of the software applications that are built on the platform from one generation to the next without a significant additional invest. So porting software, like, again, just like your iPhone, right? Generation to generation, the applications, the sensors might change a bit, but the applications have to be adapted somewhat, but you don't start from scratch, right? So for the definition of an open platform is of course, you know, the amount of applications that are being built or the amount of know-how in the industry there is to develop on that platform. You know, if there's only one person that works, you know, on your platform and that works at your company, then de facto you're not an open platform. And that's why we launched CUDA, which I'm sure some of you have heard about, Central Unified Device Architecture. It's something that's taught, you know, there's more than 2 million CUDA developers around the world at the moment. It's taught at more than 600 universities worldwide, and it's a programming language with which you can program GPUs for general purpose compute. And so fundamentally, having CUDA, having a developer base, is what we feel signifies the openness of our platform. And for AV, one of the major cost drivers for development for OEMs is software, is application development, and accessing a programmable platform that is open really does help fast iteration, and does help save costs from one generation to the next. But again, openness is not something that happens overnight. Your architecture needs to be open, and openness is partly defined by the availability of a significant developer base.
Philip, so when you're talking about architectures, and you are responsible for EMEA, I mean, are you observing regional differences in architectures across the world?
Well, I think we can all certainly say there are different architectures for autopilot AV solutions being implemented by OEMs in regions. The question, though, is that a sustainable strategy? I think when you architect such a complex system, and it's such a difficult problem to solve, adding complexity by having different architectures, different regions I don't know how sensible it is. And so we propagate a one architecture strategy, or one architecture strategy at certain layers of the system, and one architecture in the region, one architecture for the fleet, which allows you to create an installed base. Yeah, that's a global installed base for which you develop applications. And what you fundamentally do is you tailor your applications to your regions. So that we all know different regions have different requirements from a customer perspective. But there's no reason to spend the effort in redefining for every single region a different fundamental architecture. So for me, this is very much, I didn't want to use the word, but I'm going to use it as a buzzword. Software-defined vehicles, right? We all talk about it. What does it mean? But fundamentally, what it certainly should imply is that you can develop applications in different regions with the same architecture in your car, in your vehicle base. So you drive down costs and you invest where it's necessary. It's in creating different applications in the different regions. Why would I get in a car in Europe that has, and then get in a car in China that has a different computer in it? Why would that need to happen? Why would that experience need to be different? It shouldn't be. In reality, the application can be different, but it should just run as smoothly as in any other region. Anyway, that's the way I feel about differentiation between architectures in regions. Yeah.
Thank you, Philip. So before, I would like to ask everybody to come up with a final wish that you might have when you think about autonomous driving. I would also like to give everybody the opportunity, if there's anything you would like still to comment before we go into our final round, then you have the opportunity now. And if nobody wants to add something to the discussion that we shared so far, so then I would like to ask everybody about the final statement. So maybe starting with you, Philip, when you are thinking about autonomous driving and you had a wish free, what would this wish look like?
I think what I would wish is that that there is a stronger realization in the entire industry that there is already quite some technology that is leverageable, and that when you create or leverage platforms, you create momentum, and the more applications that are developed on a platform, the more momentum you create, the more value you deliver to end users and customers. So platform thinking versus starting from scratch. That is really what I would say is a very powerful thought, and I would want the industry to embrace more.
You, Philip. So Cyril, what would be your wish?
It's not so much a wish, it's more a dream. My dream is that one day autonomous driving will make mobility simpler, cheaper, safer, more accessible, cleaner, but without making humans more stupid. And keeping the ability to own and drive cars, not losing the pleasure of driving, something I really like.
Thank you very much, Cyril. Mark, what is about your wish or your dream to come true?
Yeah, I do not only want to focus on the automotive industry. I want to bring up again what Tatjana pointed out. What is really important from my perspective is that we really, and we are in a German or in the European panel at this time, that we really develop a German, a European perspective on AI, on autonomous driving. When we actually see in the regions, North America, we always talk about autonomous driving, and yes, of course, it's really, really challenging. But we see some competitors in the US, they already are driving autonomous without a safety driver. And so really the competition in the other regions is pretty fast. And I think we really, not only the automotive industry, but there also, we really have to speed up and to really find a German and European perspective on it. That's my wish, to have it in the next 2 years, 3 years. Yeah, we do not have that much time to do it.
Thank you, Mark and Wolfram. So coming to your wish and to your dream.
I couldn't agree more with everything that has been said. I mean, if I want to put this technically, right? So what I would really like to see, from my perspective, hinders us, or not hinders us, but would be a substantial accelerator if we had this. This is kind of like, if you think about what happened now with all these foundation models, and what we don't have right now is this foundation model for robotics or self-driving. And I think the pathway to this could be a scenario where we basically equip every car with the sensors and compute that allow us to actually observe the world that is going on and convert this into the World Wide Web that has been used for creating these foundation models. Right? Something like this would really enable us to take the next leap, that what we see right now happening with these foundation models. And the only way for doing this is collecting data from vehicles that are driven around by humans right now. So we basically will get these data and have the ability to convert this into a real robot and intelligent vehicle. So I call this the foundation model for robotics. And I think that touches every aspect that we have seen thus far and would be the real enabler. I have no clue how that could be realized, but I think like if we all like sit together in one table, then there might be a chance for doing this. So, would love to see this happen.
Thank you very much, Wolfram.
And that would not only impact like self-driving, would also impact robots at home and things like that. So we actually take the next leap with this.
So let's sit together at one table and solve this topic. So I think this is more than any best final word I can choose. So thank you very much to my panelists for this inspirational discussion and great contributions that you have made. I'm very happy that we had the opportunity to spend a few minutes on this topic, and I'm looking forward to observing how this topic will evolve.